Hello everyone, welcome to day 3 of distance learning. As you can see, I learned my lesson from yesterday's video and I will now be filming horizontally so that you don't have to watch a vertical video on YouTube. Please ignore this kind of crumbs from my lunch. Anyway, what we're going to be doing today is piggybacking off of what we started yesterday, which was solving systems of inequalities where you have to shade to show your solution region. So you're going to need, like yesterday, some shading material. So here I have like colored pens, highlighter, pen, pencil, and if you have colored pencils, that might work better because it won't seep through the paper. But you guys do not have these notes printed out. They are brand new notes and you can find them attached in the assignment post for today. So you can either pause this video right now and print those out and follow along with me, or if you can't print this out, then just get some lined paper or just get your math notebook and follow along with me. You should be writing these down somewhere so that you have something to refer back to when you do your work this week and next week, and just so that you have a record of it in your math notebook. So I'm going to go ahead and get started. 4.2.1 Solving Systems of Inequalities Notes. I already messed up with this video once, so I put the first 2 letters, but anyway, to solve a system of equations, graph the inequalities as if the inequality symbols were, and we've heard this so many times already, but there were equal signs. If y is not alone on one side, solve for y in order to graph. Remember, an equation needs to be in y equals, especially if you're inputting into Desmos to help you graph. You need to have a y equals equation. Also, when a line is in y equals mx plus b, which is slope-intercept form, it's so much easier to graph because you can just put your dot on your b and move with the slope. Okay, one difference though with the equal stuff is since these are inequalities, you do have to do kind of like your open circle, closed circle stuff. So the equivalent when you're doing the systems is if you have greater than or less than, which normally you would put an open circle on your number line. To show it on the coordinate plane, you know, since these are not included values, the graph is going to be dashed, or dotted. So if you're making a line, it's going to be a dashed line. If it's a curve, it's going to be a dash curve. And then in the opposite way, if it's greater than or equal to, less than or equal to, meaning that the values are included, it's going to be like equivalent to your closed circle on your number line. So you're going to use a solid. You're going to connect the line with a solid line or connect the curve with a solid curve. And lastly, for your shading, to show your solution region, if you have a greater than sign, whether it's just greater than or equal to, you're going to shade above. And if you have a less than or equal to sign, you always shade below. That's an easy way to remember. So greater than above, less than below. The solution is the region solutions rather, is the region that satisfies both inequalities, which will be the region that has an overlap of shading. To test a solution, pick a point or a coordinate, and it has to be x, y, because remember, when we're solving a system, you have both x and y variables in the inequalities, and so you have to get the coordinates that satisfy both of them, both x and y, not just the x value. When you substitute this point into both inequalities, it should work for both should be satisfied. So we're going to do 2 examples together, and the examples that you have in your practice packet that are attached to this post as well will have very similar examples, so you should be using these notes as you work. So it says graph the system of inequalities, and then we're going to shade in the solution region. I'm going to show you 2 ways that you can shade in your solution region, 2 ways that you can show your answers, and then we're also going to test a point as our last step. So let's get started. Here I know I have 2 lines because the exponent is to the first and y equals mx plus b always comes out as a line. So thankfully for these, y is already alone, and you'll notice that some in your practice packet, y is already alone. Oh, and one more thing that I do want to mention is that if you have a vertical line, the equivalent of above is shading to the right, and the equivalent of shading below is shading to the left, and that's if you have vertical lines, because you will or you might have to graph vertical lines. Okay, so back to this is thankfully the y is already alone. I know that these are going to be lines because they're y equals mx plus b, and thankfully y is already solved for, so I can just graph these right off the bat. If you would prefer to plug these into Desmos with an equal sign, that's perfectly fine. Just make sure that your graph is entirely accurate, right? You should be plotting accurate points, and that you're using a ruler to connect your points so that your line is accurate, okay? I just like graphing my lines with the B and the M. So for this one, maybe I'll just do pencil. Okay, so for this first line, I'm going to start at 0, -2, because -2 is my B and that's my y-intercept. So I'll put a dot on -2. And then my slope is the number that's in front of the x. And since it's not there, I understand that as a 1. My slope is 1, and that means I'm going up 1, right 1. So I'm going to get the rest of my points by just going up 1, right 1. And I'm going to cover my entire plane. It's important, and especially because I don't have a ruler, that I cover my entire plane. Okay, and then I'm going to determine how I'm going to connect the dots. Since it's a less than or equal to sign, right here, I'm going to just connect it with a solid line. And just forgive me because I don't have a ruler right now, but I'm going to pretend that this is perfect. And here I have a solid line. It goes on forever, even off the plane, so I'm going to have my arrows. And that was solid. I'm not going to shade yet. So for this other one, again, y is already alone. I'm just going to graph this new one. So my y-intercept is 0, 5, because my b is 5. So I go 1, 2, 3, 4, 5. My slope is -3, so that means down 3, right 1. Because -3 is the same as -3 over 1. So down 3 over 1. Down 3. All right, and then I'm going to look at this, and this has a different symbol. It's just greater than. So when you're greater than, it's not included. It should be connected with dashes. Be careful before you connect, especially if you're not working in pencil. You need to be slower with these. Here, take your time with arrows because it goes on forever. Okay, so here I have my dash line with the negative slope, and here my solid line with the positive slope. Now I'm going to determine my shading. So I'm going to grab my colors, and this is one way that you can shade when you want to shade everything, and then just draw an arrow or highlight the overlap. So for the first inequality, first linear inequality, I had a less than or equal to sign. So remember, less than, you're going to shade below. So that was my original solid line. And I'm going to shade everywhere below that, because everywhere below that satisfies the top inequality. And I'm going to use a blue pen. I'm just going to shade all this. I'm try not to cover the dash so I can keep an eye on it. Everywhere below that line. Okay, now I'm going to shade in for this one, and I'm also going to put shade below, so I have a note of that. For this one, it has a greater than sign, and greater than means above. So this one, I'm shading above. Use purple. So that's my dash line, and everywhere above is this way. So just the purple satisfies the bottom inequality, just the blue satisfies the top inequality, and you want the region that satisfies both. So that's just where the overlap is, and that's where I have both blue and purple. So because I have colors everywhere, I'm gonna just kind of use a highlighter, and for me to notify the teacher, for you guys to notify me that you know where the solution region is, I'm just gonna kind of like highlight this in. You can also kind of like take a different color, and like here I have green. And you can kind of like outline it here with the dashes, this side with a solid, like all this. Or you can just like kind of point an arrow and go solution. So that's kind of like 3 ways that you can show your solutions if you choose to do the shading for both of these, okay? Lastly, we're gonna test a point. So any random point in this region here of the overlap of shading should satisfy both of these. So I'm just going to choose something easy like 1, 2, 3, 4, 5, 6, 6, 2. Looks like it's clearly in there. And remember, it has to satisfy both. And it should, because my graphs are pretty accurate. So let's plug in. I have, can you see? 2 is less than or equal to 6 minus 2. 2 is less than or equal to 4. That's correct. I'm going to plug into the other one. 2 is greater than negative 3 times 6 plus 5. 2 is greater than negative 18. And you can use your calculator to help you with these, but I'm just doing them in my head. Negative 18 plus 5 is negative 13. Is 2 bigger than negative 13? That's definitely correct. So I know I solved this correctly because the point that I picked from my overlap worked for both of them. You don't have to choose that point. You can even choose a point that's like way out here or way down here, as long as it's in your shaded region. Okay, we're gonna do one more, and then you're gonna do your practice on your own. So this one, you can see it looks a little bit different because y is not solved for in this one. So we're gonna have to do that in our first step. And also, the second one is not a line anymore because you can see it has a squared. And remember, squareds always are quadratics. They end up as parabolas when you graph them. And I don't want to graph that by hand with a table, so I'm just going to use Desmos. So the first thing that I'm going to do is solve for y and my linear inequality at the top. I'm just going to copy it down here. Remember, when you're solving and getting y alone, anytime you divide or multiply by a negative on both sides of the inequality, you have to flip the symbol. So let's see if we have to do that here. To get y alone, I move everything but y. So on the left side, I only want y to be left over. The first thing that I'm going to do is add x. So that's 2y is less than or equal to x plus 6. And then to get y alone as my last step, I just divide everything by 2. So that's y is less than or equal to 1/2 x plus 3. I did not end up having to divide or multiply by a negative number, so I did not have to flip the symbol at all. As my first step, I'm just going to graph this line. Again, you can use Desmos if you want, but I'm just going to use my clues. So my b is 3. My y-intercept is 3. And the slope is 1/2. That means up 1, right 2. So up 1, right 2, up 1, right 2, up 1, right 2. Remember to cover the entirety of the coordinate plane so that we can see all the solutions and it doesn't just cut off randomly somewhere. And when you're going backwards, I do down 1, left 2, down 1, left 2, which is the exact opposite of this, and it gets me the other side of the line. All right, so since it's just it's less than or equal to, so that means I'm going to connect with solid. And again, I'm just going to wait for my shading till the end. If you have a ruler, it's more ideal. Again, I do not. And now I'm going to graph the parabola. And I already have it here on Desmos, so I'm just going to copy some points. The vertex is at -1. -2. I have a y-intercept at 0, -1. And then it looks like on the other side it's symmetric and it matches with -2, -1. Remember, you want your graphs to be as accurate as possible, so I am graphing accurately right now. I also have 1, 2 and -3, 2. Let me just get like 2 more points. So it looks like maybe here, 2, 7 and -4, 7. Okay, so there's my parabola. I kind of did enough that I can see the full shape right now, and I'll fill up the coordinate plane. So here is going to be solid as well because it's greater than or equal to. Remember, it's including, so you connect with a solid. And see how I'm taking up the entirety of the coordinate plane that allows me. And it should look like a U-shaped parabola. Okay, here's another way that you can do your shading if you didn't want to use like all the colors and highlight the overlap or draw an arrow to the overlap. You can literally just see the overlap ahead of time and only shade in the shape that it makes with the overlap. So I'm just going to, this one I'm going to be shading below because it's less than. And this one I'm shading above because it's greater than or equal to. So if I'm shading above the parabola but below the line, let's see ahead of time. I'm gonna do purple. So above the parabola, but below the line. Above the parabola, but below the line. Well, the only region that has both above the parabola and below the line is just this right here. So that's my solution region. And if you would like to, you don't have to, but you can also draw an arrow to your solutions. So again, if you used all your colors, one shading for the line, one shading for the parabola, and you did your overlap, it should still be in the same space. So below the line, above the parabola is the purple. Again, I'm just gonna pick a point and test into my system. So here, I'll just pick one like right in the middle, -1, 1. I'll try -1, 1, and it should work. So I'll plug into the first one. You can plug into here or the original. I'm just gonna go into this one because they're equivalent. We just got y alone. So 1 is less than or equal to 1/2 times -1 plus 3. 1 is less than or equal to -1 times 1/2 is -1/2 plus 3. 1, and again, you can just put this in your calculator, but -1/2 plus 3 is just 2.5. Is 1 less than or equal to 2.5? Definitely is. And then I'm going to plug into the other one as well because it has to work for both. So 1 is greater than or equal to -1 plus 1 squared minus 2. -1 plus 1 is 0. 0 squared is 0. And 0 minus 2 is -2. Is 1 bigger than or equal to -2? It sure is. So I know I got the right solution region because the point that I tested that was in there worked. So that's basically it for these. Your task right now is to either print out your classwork packet, your work for today, or do this work on graph paper. If you do it on line paper, your graphs are probably gonna not end up accurate. And again, I've stressed many times it is important that your graphs are accurate for this so that you have the right shaded region. So grab your graph paper. You can also print some out. I posted some in the attachment. Or you can just print out this packet. So you have 9 problems to complete. You have 2 days to do so. So this is Wednesday that I'm assigning it, and it's due by tomorrow night, Thursday, March 26th by midnight. So just complete those 9 problems. If you're in my Block 4 class, you only have 8. So please grab a ruler, grab your colored pencils, pens, highlighters, grab your Desmos, that'll help you graph, and just do as I did on the notes. So here, thankfully, y is alone. Who remembers what that looks like? Y equals 3 when you graph it. Or even this one. What does x equals -3 look like when you graph it, okay? Remember to use Desmos if you are unsure. See these, y is not alone. Make sure you get y alone. Make sure you flip if you had to divide by a negative, flip your symbol. And again, if you see like these parabolas, use Desmos if you would like to graph. Otherwise, you are using a table. But I'm sure most of you will use Desmos anyway. Thank you so much for watching. And also, since you have 2 days to complete these next 2 days, possibly tomorrow if you're already done, is a really good time to do your quiz corrections. And make sure you can ask me questions on those. They are due Friday by midnight. Again, thank you for watching, and I'll catch you later. Bye.